Hi, my name is Adriel, student ID 03479799. Course is Bachelor of Engineering with Honours in Mechanical Engineering. This module is Engineering Mathematics 2. My intake is in March 2021 and the year of recording this is in 2021. So the title of this assignment is Ordinary Differential Equations and its Application in Food Industry. So the descriptive title that I have chosen is the cooling rate process of brownie in a cake factory. So what is an ordinary differential equations, short form for ODE? So an ODE contains one or several derivatives of an unknown function, example y, with respect to a single independent variable, which is x. So in this assignment, I'll only focus on first order ODEs, which consist of linear equations, separable equations, exact equations, Bernoulli's equation, and substitution and modeling. So modeling is taking physical, real life application and transforming it into mathematical terms to solve and obtain the results that we want. So first order ODEs contains first derivative of a function with respect to an independent variable. So for example, y prime is a first derivative with respect to x, the independent variable. So this is the question that I have constructed. You can actually pause the video and read through to further understand it. So these are the conditions obtained from the question. So we are to find out the time taken for the brownie to cool from 180 degrees Celsius to 30 degrees Celsius. So here we are using the Newton's law of cooling, and the Newton's law of cooling equation is this. So we bring the temperature to the left side and the small t, which is time, to the right side, integrate it, and we can form this equation. So from the previous slide, this is the equation that we obtained. So these are the conditions from the questions. So by applying the first condition, we can obtain the value of C. So from the value of C, we put it back into the equation. And then from this second equation, we use the second condition to obtain the value of K. So we then put the value of K into our equation, which is the third equation, and we apply the third condition into the third equation, and then we can then find the value of small t. So the time taken for the brownie to cool from 180 degrees Celsius to 30 degrees Celsius is 9.46 minutes. So you can pause the video and understand how I actually obtain the value of t based on ODE equations. So here I've constructed a graph based on the equations I've obtained. So this is the third equations that was formed in the previous slide. So by putting this into graphical terms, we can see the graph here. So at 0 minutes, the brownie was at 180 degrees Celsius and it cools exponentially until 25 degrees Celsius. So to the right side is the zoom in figure. So when the brownie cools until 30 degrees Celsius, the brownie actually takes 9.46 minutes for it to cool from 180 to 30 degrees Celsius. So this is the references that I have taken to obtain the Newton's law of cooling. And so this is my presentation for applying ODE into food industry.